the volume of a cube is increasing at a rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of the edge is 12 centimeter? So what exactly they're talking about? See, things are changing with respect to time. Okay, so you need to understand that we have a cube which is increasing in its volume with respect to time. Something like this. Right, you have a cube. Now this is with respect to time. So every second we can see that. Right? So it was increasing. So it came from this to this. Okay, so let me. So this is what is happening. So we had actually, my bad. So we have something like this, some scenario like this. So we have the following scenario. So for every second, say this is 1 second. If this was say 10 centimeter cube, this will be 18 centimeter cube. Right? In 1 second, there is an increase in volume by 8 centimeter cube. Okay. So if this keeps happening, when the edge, so we have the edge, those are your edges, right? When this is 12 centimeter, the question is, when this happens to be 12 centimeter, so what is the area, right? Surface area. So if we go back to this and if I change the perspective, something like this. Now if I play the animation, so we can see that even the area is increasing, is it not? Okay, it came from here till here. Obviously, right? If the volume is increasing, the surface area has to increase. In this manner at least. You guys agree? So they're asking what is the rate at which this is increasing, because not everything will be increasing at the same rate. The volume and the area and the length, they increase at different rates. Now the point is, what links to the volume to the area? The question is, what links the volume to the area? How can I link this to? What quantity links this to? Yes, the edges. The rate at which the volume is changing with respect to time. And we have to look at the rate at which the surface area is changing with respect to time. And the quantity which links all of them is the length, the edge, the rate at which the edge changes with respect to time. So you can see over here, if I take up any edge, so that is your perspective. Okay, so look at the edge. Now let me play it. You can see the edge, right? Even the edge is increasing at its own pace. So if I am able to find the rate at which the edge is increasing, I'll be relate that to the area, and so we'll be able to find the rate at which the area is increasing. Okay, so this is how everything is linked. Because with increase in edge itself, your volume will increase, and with an increase in edge, your area will increase. So this is the common factor, right? Now we can start the answer. So very first thing is, we will need to talk about how the volume and the area is related to the length. Okay, before that, let me write the given. So rate at which the volume is changing with respect to time is 8 centimeter cube per second. Then they're asking us to figure out the rate at which the area is changing and the length is 12 centimeter. Now the working. Volume of a cube. So we need to start off with that. We'll represent this with V of L. That's L cube. Then surface area of the cube. We'll represent this with A of L, which is 6L square, right? Right, we'll do mention about L being the length of the edge. Now, we'll consider the first expression, volume. So we need to differentiate this with respect to time, right? We are looking at how things are changing with respect to time. So we'll end up with dV by dt is equal to 3L square and dl by dt. This is as per the chain rule. See, whatever is changing, see, we are differentiating with respect to time. Length is also changing with respect to time, is it not? As per the chain rule, I need to differentiate L square, obviously L cube in this case, and I'll end up with 3L square dl by dt. This is where you guys have to understand how all of this links. Okay, and finally we have this quantity 8. So this is 8 equal to 3L square dl by dt. I won't substitute anything. Therefore, dl by dt is equal to, or you don't need to write this. We'll just call this as 1. Okay, again, you guys are not in kindergarten, not in 6th, 7th, 8th grade. So I would like you guys to manipulate and make use of things, right? And do what is required. Just don't go behind getting a value and substituting and all of that. No one cares about that. Final answer and your methodology is all they care. You guys are matured right now. They don't want numbers. They want methodology. So next is you're looking at area, obviously. So we need to differentiate area with respect to time again. So dA by dl dt is equal to 12L dl by dt. Again, with respect to chain rule, we'll end up with this. So now we are looking at dA by dt 12L and dl by dt as per equation 1, it is 8 by 3L square. 8 by 3L square. This is from 1. See, that's what I mean. Here you can see what will happen. 3 1s are 3 4s are L and this will get cancelled. See how things got convenient, right? And finally dA by dt at, I think it is 12. Yeah, it's 12. This would be equal to 4 into 8 by 12. Okay, and finally we have 8 by 3. Area has to do with centimeter square, the unit that is, and this is second. Okay, and we will end up writing area is changing at a rate of 8 by 3 centimeter cube per second at L is equal to 12 centimeter. So that's important for us to conclude and do underline. Yeah, that will help your teachers for correcting. Okay, I hope you guys understood how you have to think and how things get linked. If you understand this question, things will be easy. Again, understand the basic underlying concept, how things should be linked and how all of this are linked to each other. right? How factors like time can come into picture, wherein time is nowhere close to expressions like volume and surface area. There's no time factor over here. But yeah, things will change, things will change with respect to time. I can increase the volume with respect to time. I can increase the surface area with respect to time. So this is the basic fundamental thinking that you guys have to have. Now you can pause and have a look.